You are given the zero index integer numbers and queries both ends and in the ice queries, the elements index are removed, splitting into a different segment. And the segment is a continuous positive integer. Segment sum is the sum of every segment. Maximum segment sum. Index. So I want to do the query reverse. It's we add the first segment is going to be 1. We add 2. Now we add 2. Right, so find the maximum segment sum for each query. Do it reverse and use union find to merge the sum. So and maintain maximum when we union. Maintain a maximum set. When we union to index. But so what we say? And I say parent. So if both is the same, we return it. We also need a sum. Let's say the sum is 0. And right, so sum y add about sum x. Erase about find sum y and find sum x. So basically set, you can say these numbers, setting insert by x. And 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 we want to do reverse. First is that we queried, we will not add, we will add indexes, remove query, and we add this index. Wait. You want to sync? Right, so we do this now. We will add some first erase the sum as erase 0 and insert value. So we ask and want to union. So I use point set. To check that union is count. Now we union about the index is -1 if index count index at 1 union at 1. Right, that's it. We add this index, so erase 0. Oh, wait, some index right, that's it. Yeah. Because we need to initialize. Okay, shifting letters. Even about string and lower English letters. Since this following. Given about a binary string in 1 second, all occurrences on simultaneous surface 1, 0. The process repeats until no occurrence. Numbers of second. Can we simulate it? Wow. We'll find the minimum time that to no 0, 1 pattern, right? Right. So So what it means? It means that 0, 1 will change it to 1, 0. 0, 1, 1 will change into 1, 0, 1, and 1, 1, 0. So it's actually moved to the Alright, so I want to simulate it. Means the change. And no change. Right, I don't need this. And this guy should be 0, 1. that means we should change it. So SI is going to be right, that's it. Oh, right is not very good. So yeah, that's it. So given about 0 index, Ross and Airbus is here Y bra. Or B represent the color ice bar. The corrector red and black denote. Okay, so it's white and black. So given about the integer, which is design numbers consecutive black, what means in one operation you can reorder a white or recolor. Okay, so this one occurs K consecutive. Right, so find the minimum operations need to require the blocks. Okay, here's sliding window with size K. Calculate the maximum black blocks. Right, and okay, minus maximum. That's it. Okay, so in this one you are given a string, shift, start and direction. Inclusive forward if direction is 1, backward. Forward means that oh, got an idea. So find a final string. Right, so after apply shift, actually it's like nicely how we do. So in each shape just add left. If direction is 0 we add 1 because we move forward. Forward is 0. Forward is 1 if 1. else if directions once, else add the -1 or I don't know. Right, that's a nice mean. So we can use the operations and integrations. Shift. The F is OP0, R is OP1, direction is OP2. So if direction else, so OPS L will add 1, OPS R -1, central. And then we will get an answer. Is the lowercase, say the characters. So it's C will add about operation. That's it. Right. What? Oh my god, what happens? Inclusive, so 0 we will add it to shift the character from index 0 backward, -1, backward is -1. Want to see what is the final operations in this. A never change it because we will have 1 -1 and this last week. Direction is the okay, I know, good. Let me get an idea. Right. That's it. Over 4. Oh, it's overflow. Damn. Right, that's it. Damn, that's too much time in this problem. Right, so right, doesn't matter. Yeah. Sync. Yes. Oh, 1 penalty. Right, let's see this problem. Cool. So, this problem is that you given about 0 in the string is a block, and we can carry it to white or black. And I want to find out that what is the minimum operation that need to make this string to at least k consecutive black blocks. And actually, at least one doesn't matter. Is no use. If 2 occurrence and 1 occurrence is just the same, so we only calculate the 1 occurrence. What is the minimum required to get k consecutive, to get 1 k consecutive black blocks? So in this problem, we just use sliding windows. We can get and what is idea is that because k is more than n, so we first add a black, calculate the black number, and then after that we can get that is the maximum black consecutive in the k sliding window, in the k window, k size of k window, and then we just try to shift the window. So in this case, 1 2 3 4 5 6 7. After we shift window, say in this case say 7, right? So it's 1 2 3. Right, so it's nice. So now get it. It's will not shift to this. We will add about current is black or not, and we will minus about this I minus k. So I minus k is that current is 7. This is 7, 8, 9. So yeah, that's it. 7 minus 0, so we minus white. So now the black is still be 4 because b is 4. B still be 4, and then after in I is equal to 8, and now we will subtract the b to 3, right? And the maximum is still be 4, and in this window we know that. Oh wait, this subtract 1. Let's get 4, and this is 4. And this window is 4, right? Oh wait, restart it. In this window we have maxima is 4 and b is 4. Now we move to this index. So starting from this index, 0, 1, 2, 3, 4, 5, 6, 7. Wait, let's starting from this index. We will minus. This is I minus k. This is I. Okay, that looks well. So yeah. So the b is not increasing, and b is not decreasing. So I move to I to this. So now b will add 1, still be 3 and 3. Now in this case, we get it is that we minus. Oh, this will be 5 because we. Wait, this will be 4. Sorry, this will be 4 because we minus this b and add this b. In this case, we minus this b, so now b is going to be 3, and we add a y. That's it. And yeah, so the maximum is 4, and we just k minus maximum value. Yeah, so that's the idea. Sorry for my bad dry run. Time complexity is going to be linear, and the space complexity is going to be constant. Yeah. In this problem, is that you need to replace the string all occurrence of a 0, 1 into a 1, 0, and you need to calculate what is the minimum numbers of seconds that need to complete this process. So because the string is small, I simulated, but I think there is more efficient approach to do that, but I just lazy to figure out that. But I think we can just record all 0, 1 pattern, and if we change, we can do linear because 1, 0, 1, we will shift the 1. We will what? We will shift the 1 to. We will shift this 1 to. Wait, 0, 1. We will 0, 1 will shift all 1 in this, so we can get is that actually we can calculate numbers of 1, right? Is this, we just calculate the suffix numbers of 1, we can get an answer, because if but you need to careful that if this is 0, 0, what is the numbers of operation? First is that still be 3, right? So 1, get it? 0, and then 1 per second. Second, you get 1, 1, 0, 1, and 3. So I can observe that we just calculate the suffix of the 1. So I can do is that is this workable? If SI is 0, maximum time and 1, that's idea. Yeah, I think this is a greedy approach. Alright, so it's not because we in this case, yeah, I think there's a linear approach. Alright, so we can use another idea is that you can use map to or use a linked list to do that, to efficiently check the OR pattern. Yeah, so we can simulate it. But in this case, we just let's explore my approach. Is that in each for loop, we will check that if is it 0, 1. If we exit it, we change it, and because 0, 1, 2, 1, 0, and we never use the 1 because we must forward our index to the, for example, 1, 0, we must forward I to this position, so we plus 1, and in this for loop we will plus 2. So if we have a swap, that means we forward our index to state 2 steps. Yeah, that's idea. And time complexity is space is 1. Yeah, that's it. And yeah, alright, so that's a problem. Actually, you can use a linked list to do, maybe you can do linear, because each pattern is independent. Yeah, because in each position we only can swap 1 time. Oh, wait, no. If we have a lot of lever. Yeah, so maybe I don't have a good idea to do that. Yeah, because in these cases, because we have a lot of 1, and we will do many numbers of time. So yeah, I think I still need to think about how to solve when n is very big. That's it. And let's say in this problem 3 is that you need to calculate. You have the string with the lowercase letters, and you given about a 2D integer array, the shift. That is means that start, end, and the directions. So in each operation, if the direction is 0, we will shift backward. What it means backward is that a minus 1, so a will going to be the previous letter, and we'll get z. So yeah, so what's the idea? The idea is that we can actually you can simplify these operations. We just only do one times. We do all operation in one time. How do we do? We can use a nice sweep approach. We can add the left position, right position to if the list is at 1, we just add this range, because this is we only change because we have a lot of index. We don't need to for loop to add 1. We just add the boundary point to this boundary point, and a 6 for minus 1. So if we do a prefix sum, we will get 1 1 1 1 1 1 0. That's the idea. So we only add a boundary point. What is boundary point? Is the shift position, right? So idea is that we only calculate the boundary point. This will take linear. And the linear is the shift length. And after that, we do a prefix. So it's OS. So shifts length and linear. Finally, we just do all operations at once. So we calculate the integer value and we add an operation, and we should model the value. If this is a negative 1, we should make them to 25. That's the idea. And careful about more value. You should make sure that C is in range. Make sure C is 0 to 25. Yeah, that's the idea. Space is linear, and time is linear. Yeah, this problem. And about problem 4 is that you given about the integer array in a given amount of query, and in each query we will remove an integer in this index. For example, 0 means erase index 0, erase 1, and we need to find out that the maximum segment sum in these numbers. And actually, it's have to a lot of offline query problems. And so in this problem, we can do offline because remove the interval is hard. So we can think about how to merge the interval. So we do it in reverse to make a problem into a merge interval problem. So we do it reverse, and we use a union find to merge two interval. If say my idea, so 1 2 5 6 and 1. If we don't have this, and if the query is the 2, we will connect it to union this guys, union this guys, and union this guys, and union this guys, and just maintain a sum of the loot. Each segment sum and segment maximum. We just need this information. We can use the union find approach. We just erase the both, because we need to merge them. So we erase both sum and merge them and insert a new sum. That's the idea. And need to be careful about a single node, because the segment default value is 0. So when we add index, we should add length is 1 value That's idea. So we do it reverse and then use our set to record the index, and then you get the current index and add about the index to the sum, because this is unique, so the sum is never be positive number, always be 0. So always 0. Initially always be 0. So we add this index and push it and add a single number on a merge interval. We just check that if the index is connected, is adjacent. So we can merge the interval. Merge them. We calculate the maximum sum of this. Yeah, that's the idea. And the time complexity is going to be, in this operation, is log n. This is all 1 because we have multi-step. So yeah, that's it. Total time complexity is n log n. Yeah, n log n. That's it. Well, let's see my final ranking. Right, because I have 1 penalty. So, alright. Thank you for watching this video.